Welcome to the 43 session of LMS. Program is for BSc students. Subject mathematics and semester is 5th semester. The title of the paper is Numerical Analysis. The finite difference is the third unit of the numerical analysis, where we are studying today the problems related to the method of separation of symbol. If we go for the recap, in the last session we came to know what is the meaning and definition of the separation of symbol. Now at the end of this session we can able to solve the problems related to the separation of symbol. So problems on separation of symbols. So first problem or first example is, by separation of symbols we have to prove that u of x is equals to u suffix x minus 1 plus delta of u of x minus 2 plus delta square of u of x minus 3 dot plus delta to the power of n of u of x minus n. Right? So now we will solve this. Here we consider the terms. Here we are considering the terms this and this. That is, we are going to move this term to the LHS, that is this side. Here we are moving LHS. So we are considered here. You can see it. First and last term has been considered here. Right? So first and last term has been considered here. Now this can be written as, you can see it here, u of x has been written as it is. U of x is written as it is here. U of x minus this delta to the power of n written as it is, but this u suffix x minus n is written as e to the power of n minus 1 times of u of x. So how we can write this? This is shift operator. That is shift operator, I can say. How it is? I'll show you. The shift operator definition is, we can say that e power n times of f of x is equals to, we can say, f of x plus n nh. But we know this. If you replace here by this and this by u suffix x, as we know that separation of symbol, that is e power n times of u suffix, that is u suffix x, is nothing but an, I can say, u suffix x plus n h. Right? n h, I can say. But this is the terminology where we can write it. Right? So we will write that by using the shift operator. We can able to write this here. That is, this part is written here, e power n times of u of x, by, instead of this one it is e power n, minus n is there, therefore minus n u of x. Right? Now in this 2 I can take u of x as a common. I have taken it. Now e power minus n can be written as 1 divided by e power n. Right? Now you can see here, just I have taken the LCM. U of x is here and e power n minus delta to the power of n will be there. So what I can do, 1 divided by e power n I have taken outside. That is nothing but an I can say, where I is the identity operator. Right? But I can be written as this. I can be written as e minus delta. Right? So if you write this one, these terms can be expressed as like this here. E power n minus 1 plus delta into e power n minus 2 plus delta square of n minus 2 plus delta to the power of n minus 1. and remaining terms has been kept as it is. Now I will move this e power n inside. That is 1 divided by e power n will be moved inside and it will be taken to the numerator. So what happens if I will take this will be multiplied with e to the power of n minus 1. So e to the power of n minus 1 divided by e power n will be there. Here if you multiply these two things, what happens? E to the power of n minus 1 divided by e power n will be there. You can move this one to the numerator. It will be e power n minus 1 minus n. So n get cancels. Remains is e to the power of minus 1. You can see. So similarly with this I can do it similar steps. So I can get it as delta into e to the power of n minus delta to the power of delta into, just I am writing the brackets, it has been removed. So it is nothing but an e to the power of minus 1. If you multiply this term, this with this, it will be remaining thing is e to the power of minus 2. If you multiply this with this, it is e power minus 3. Like this, up to n terms if you multiply, we will get e to the power of minus n. And we have kept this u of x outside. Here is also u of x is outside. Right? Now in the next slide. In the next slide you can see it here. What we have done, that we have brought that u of x outside u of x inside. We have multiplied with each and every term. Right? After that, if you rearrange that shift operator by shift operator, that is e power n times of f of x is equals to f of x plus nh. Like that. So it can be written as u of x minus 1. Similarly, this one delta has been kept as it is, e power minus 2 u of x, that is u of x minus 2. Similarly, delta square has been kept as it is. This term, that is e to the power of minus 3 u of x, can be written as u of x minus 3 plus dot dot dot, and the last term, this one can be written as u of x minus n. Right? So now you can see that we can move this term to RHS. Right? If you move this one, here we have wrote it. Hence, this is my required proof. Right? We have proved that u of x is this one. Right? So now I will take second problem. That is second example. Prove the identity. This identity we have to prove. u0 minus u1 plus alternate plus and minus signs are there. u0 to up to dot dot dot, and we have to prove this one. Now I will consider the LHS. Right? So LHS is u0, u1, u2, all the things we have considered it. Now same thing I will apply and write this all terms, that is u1, u2, u3 in the form of e. Okay, shift operator e, and all u's will be in the form of a u0. You can see it here. u1 can be written as e to the power of 1 into u0. U of 2 can be written as u0 e square u0. Like this I can write. In all this you can take u0 as a common. So this is nothing but an 1 plus e to the power of minus 1 it will becomes. Right? So now you can see it here. What is this e? E is nothing but an 1 plus delta. We have wrote here. Right? 1 plus delta, it is nothing but. What happens? It will become 2 plus delta to the power of minus 1 of u0. Right? So now if you multiply this by 1 by 2, outside and inside, what happens? 1 plus delta divided by 2 terms of e to the power of minus 1. Right? So now that this term, that is 1 plus delta divided by 2 to the power of minus 1, can be expressed as, here it is, expression is here, 1 minus delta divided by 2 plus delta square divided by 4 minus delta cube divided by 8, and u0 and 1 by 2 kept out. If you bring these two inside, I will get the RHS. You can see LHS is equals to RHS, hence the proof. So similarly, another example we will take. we have to prove this identity by method of separation of symbol. That is u0 plus u1 divided by 1 factorial of x plus u2 2 factorial x square plus dot dot dot. It is nothing but an e to the power of x of these terms. Okay. So now I will take that LHS. LHS has been considered here first. So first what I will do, I will write the u in terms of u1, u2, u3 in terms of u0 with using the shift operator e. Here it is, u0 is like written as it is. Here x divided by 1 factorial, u of 1 can be written as e of u0. Similarly, u2 can be written as e square times of u0 plus dot dot dot. Now what I will do it, I will take outside here u0 as a common. Here we have taken it, right? Here you can see this is nothing but an e power theta. That is e power x. Here it is expression. This expression looks like this. E power x can be written as 1 plus x divided by x factorial plus x square divided by 2 factorial plus x to the power of 3 divided by 2 factorial 3 factorial plus dot 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 dot. It will goes like this. So in that way I can express this as e power e into shift operator e, and u0 has been kept outside. Now what is this e? Now what is this e? You can see here. What is this e? E is nothing but an 1 plus delta, right? So we are writing that. Now e to the power of x into 1 plus delta into u0. Now I will multiply this x inside. So you can see it here, e power. Just I have multiplied this x inside. This x inside. So e power 1 into xx plus x into delta x, right? Now what happens? This one I can separate these terms, e power x as well as e to the power of x into delta u0 will be there. Now this can be expressed as e power theta type formula, exponential formulas. So this is nothing but 1 plus x into delta divided by 1 factorial x square delta square 2 factorial plus dot dot dot. We have kept that e power x and u0 as it is outside. Now I will bring this u0 inside, right? So I have multiplied it here. E power x is outside as it is. This is my final answer. I can say, you can see it here, e power x into, which is nothing but an RHS. Okay, so some of the books for references are here by G.K. Ranganathan Swami and Jairam Prabhakar. So many people have wrote the textbook. So these are the textbook which we will refer. So thank you friends.